Hi, welcome to my channel. Today I'm going to show some example Python functions for games in Blender. And I'm using Blender 2.79, which still has the game engine. I think that a lot of the scripts I'm using should work in UPBGE, but I haven't tested it and some changes might need to be made. So these first few functions set game options. Engine game switches to the game engine. Reso sets the resolution in the game window and then the embedded window. Full sets full screen. Frame extend gets rid of the black bars at the top and bottom of the game window. Debug enables debug. GLSL allows the use of textures and some other features. It also messes up the view in the embedded window, so I usually enable it after I've worked out the bugs in the game. Mouse cursor shows the cursor in the game window, which is not the default. Logic sensor options returns a dictionary of options for sensor bricks, and the values in the return dictionary can be set, and then the dictionary can be passed to the main logic function to implement logic systems. Logic controller options returns a dictionary of options for controller bricks, and there is no logic actuator options function because actuators don't have options. Logic sensor dictionary returns a dictionary of options for specific sensor types, and this very large enum is for the keys that can be passed to the keyboard sensor, and it was copied from the Blender Python reference along with the rest of these key value pairs, and the Blender Python reference can be downloaded online. Logic controller dictionary and logic actuator dictionary are basically the same. They return a dictionary of values that can be set and then passed to the logic function to create logic bricks. Logic is the function that adds logic bricks, sets the values and options, and links everything together. Sensors, controllers, actuators, and properties are shortcuts. Property creates a new property, and prop set sets an existing property. Property from dictionary creates a new property for each of the key value pairs in a dictionary. Prop from key value is used by property from dictionary to add one dictionary entry. Prefix adds a string and a period separator to the beginning of all objects in a scene, and that's important because two objects can't have the same name even if they're in a different scene. Scene object adds an empty to the scene and adds some general properties like character names and a boolean that tracks if the character is active. Input adds basic keyboard, mouse, and joystick functionality. It loads the input py script, which looks like this. And the controls are somewhat specific. The WSD keys are hard-coded, and mouse look is implemented for controlling the camera. Click left and click right detect a left click and a right click. Pathonet takes a list of object names and adds properties that make objects walkable so the character doesn't leave a path. Path check adds a set of empties around a character that disable movement if the character is moving off a path. It loads the path.py script, which looks like this. And this uses Blender's raycast function to check if the object below the character has the path property. It's there. The character function adds a set of properties and scripts that are used for moving and animating characters. It first loads the Groundcast script, and that looks like this. Starts off with some basic vector functions. And basically what this does in general is it places the character at the height of the ground. So like the path script, it casts a ray down and it gets the point where the ray intersected with the ground and sets the character at that point. The next main function that the character function calls is cycle, and cycle uses 2D kinematics to create walk and run cycles, and the script it loads is this one. Ellipse draws an ellipse around an actual object that has to be parented to the body of a character to emulate movement animation. IK2D is an inverse kinematics function. It finds the angle for a root and child bone if their lengths and destination are known. Cycle path cycles through a set of 2D points which serves the same purpose as the ellipse, except it can create a more customized path for the arms and legs to follow. Basically, it does simple interpolation between the points to smooth the movement between the points. And cycle combines the functions together. The main function reads variables and triggers the movement animation, and it resets the limbs when the character stops moving. I might do a video that goes into this system in more detail. If all this seems confusing, it's probably because it's not clear how the different functions are connected. Once you see how it's all linked together, you'll realize that it's actually pretty simple. And like if most people you prefer to rig and skin your characters to create actions, you can modify these functions to key the rotation of bones in an armature. And the next script loaded by the character function is move.py. And that looks like this. It reads the character's speed and direction and updates its movement. It also sets the character's Z height based on the variable that was set in Groundcast, and it does a couple other things. And the last function of this function is path check. And I already showed that script. Groundcast is called by the character function. Cycle reads character attributes like the length of the bones. And to make a cycle path, I convert a circular curve to a mesh, then I read its points. Cycle writes the points of a path to a file, and is called by the blend file that holds the path. Cycle reader reads the list written by cycle write and creates properties for the game script to read. Action dictionary loads parameters for jog animation. Axle set sets the location of the axles around which the arms and legs of a character rotate. Blink hides and hides the eyelids of a character, and the blink.py script looks like this. Motion simple adds simple WSD controls to an object. And the script looks like this. Controller links keyboard and mouse or controller input to the movements or actions of the character. And the first script it loads is controller.py, which looks like this. And this reads input from the scene object, and it stops input if the character goes off a path, and it controls the animation cycles. The next script loaded by control is lookx, and that rotates the camera around the character. And it basically reads horizontal changes in the mouse and converts it to rotation. The character camera function parents a camera to the character. It adds the camera.py script, and that controls camera zooming and switching between characters. Those are all basically the same vector functions in every script. The look-y function rotates the x-axis of the camera based on the y change of the mouse. lookx Blender uses Blender's built-in actuator to do the same thing as the lookx script you just saw, except Blender does it a little better and more efficiently. I just like to write scripts from scratch so that they can be ported to different languages and platforms, and I think that you learn more when you do yourself. And the 2D pathfinding functions can be used to move a game object around obstacles. The paths around obstacles can't be changed in real time since these functions pre-compute them. Obstacle reads a list of prefixes and returns a list of matching objects. Mark places 4 empties around all objects in the obstacle list so that AI characters can have a path to navigate around them. Path list reads the markers from the scene created with mark and adds their locations to a list. Path mesh turns the list of vertices returned by path lists into a single mesh object with a vertex at each marker. And that's so that Blender's shortest path function can be used to find the shortest path between any 2 points. And path mesh calls the ray function, and that checks if 2 markers have a line of sight between them. PathPrintAll uses Blender's shortest path function to write a Blender game script that returns the next node on the list towards the destination. PathPrint batch does the same thing, except it opens a new instance of Blender for each path node, and that can be faster because the printall function generates a lot of garbage geometry that gets cleared when Blender is restarted. And the pathLoad function loads the pathfinding script into a game object. Pose creates variables used by the pose script to animate characters, and I'm not going to show the pose script because it's kind of a big mess. I need to clean it up. Dialog loads text and images into new scenes that can be triggered as overlay scenes using the scene actuator. And array casting scripts are used to cast arrays. Array export reads a list of objects that are meant to obstruct array and writes their geometry to a file. It also writes the object's bounding box to a file. And the bounding box can be used to speed up the raycast if you don't need accuracy. It can also speed up the raycast by skipping the reading of an object's geometry. And it first checks if the array intersects the bounding box, and if it does, then it moves on to reading the geometry. And in this function you can set a static option to indicate that the obstacle will never move, and that will convert local vertices to world space and prevent it from having to be done at runtime. Array loads the list created with array export onto a game object, and the array.py script it hasn't been tested, but I think it should be close to working. Distance to intersection finds the distance from array's origin to its intersection with an infinite plane. Bounds checks if a hit point on a plane is within the bounds of the polygon's edges. And array combines the functions together. TranArray reads the scale, rotation, and location of an object. Obstacle tran converts the local space of an obstacle to world space. Tran3D is used by obstacle transform. Scale apply applies the scale of an object. Quaternion rotates a 3D point around an axis. Main reads geometry from variables and implements options. Audio loads sound files. And here's a script for that. And the rest of these functions are in the wrong library. I spent a little time updating the array function since it's used by pathfinding and array casting. And these functions are the same as the ones used in the array game script. Bounds to geometry reads the XYZ maximum and minimum bounds of an object and returns a mesh. And that's so that it can be checked for an intersection with array. These next functions are shortcuts. Layer returns the current layer of an object, or no, I'm sorry, it returns the current scene layer. File path separates the directory and file name of the path to a blend file. Tran apply 3D converts local space to world space. Obstacle transform prepares obstacle geometry to receive arraycast. Object over returns the object in a scene that is beneath the selected object. And I think it might not work in some cases, but it might work in others. And finally, sort by connected arranges a vertex list in the line by reading how the object's edges are connected. And this is used by the path print function for pathfinding. And that's it. Thanks for watching.